So this is problem number 17 on the gas packet, and this problem wants us to find the empirical formula and molecular formula of a compound that contains only carbon, hydrogen, and oxygen. So one of the first things that we're told is that this compound contains 0.0350 grams of a compound, and that this compound made 0.0411 grams of H2O. So the first thing that we're going to do is find the percent of H in this. So we have 0.0411 grams of H2O. So we get the molar mass of H2O, which is 18.02 grams to 1 mole of H2O. Now we have 1 mole of H2O, and this has 2 moles of H. And then now we know that 1 mole of H has 1.01 grams. And after you multiply all this out, you should get 0.00461 grams of H. And to get the percent, we're going to divide by the total compound, which is 0.0350 times 100. And after you do all the multiplication of this, you should get 13.17% H. So now the next thing we need to do is find the percent nitrogen, and the information that was given to us for that, it says that we have 0.0652 grams of this compound, and that it was analyzed for N2, and it gave us 0.0356 liters at 760 torr, and that's equal to 0.974 atm, and at a temperature of 25 degrees Celsius, and that's equal to 298 Kelvin. So we gotta find the moles of N2, so we're going to use the equation PV equals nRT to solve for moles, and that's going to leave us with N is equal to PV over RT. So we have N of N2, the moles of nitrogen, is going to be equal to the pressure, which is 0.974 atm, times the volume, which is 0.0356 liters, and then we're going to divide that by R, which is 0.0821, and multiply that by the temperature, which is 298 Kelvin. And after you do all that, you should get 0.00142 moles of N2. So now we're going to find the percent of nitrogen with this. So we have the 0.00142 moles of N2. So we have 1 mole of N2 has 2 moles of N. And that we know 1 mole of N has 14.01 grams. And after you do all that, after you multiply all this together, you should get 0.397 grams of N. And then we're going to divide this by the total amount of compounds again, which is 0.0652 grams times 100. And then this should give us 60.9% N. Now the last thing we need to find is the C. So we're going to assume we have 100%, so we have 100 minus the percent of hydrogen, which is 13.17, minus the percent nitrogen, which is 60.9%. And after we do the subtraction, we should get 26.0% carbon. So with this, we can find the empirical formula. So we have carbon, which has 26.0. Hydrogen was 13.17. And nitrogen is 60.9. So we're going to divide each of these by their mass. So carbon is 12.01, hydrogen was 1.01, and nitrogen is 14.01. And after we divide all those, you should get carbon will have 2.16, nitrogen will be 13.03, and nitrogen would come out to be 4.34. So we're going to divide by our lowest number, which is the 216. So divide all of this by 216, which will leave us with C, H6, and N2. And this is the empirical formula. And to get the molar mass of this, we count the carbon, hydrogen, and nitrogen all together, and that should give us 46.09 grams per mole. And we're going to use this later to get the molecular formula. So the next thing that we have to do is find the molar mass of the compound using the rate equation, which is going to be rate 1 over rate 2 is equal to the square root of the molar mass 2 over the molar mass 1. And the information for this is we're given that we have 38.2 milliliters per minute of an unknown gas over 58.0 milliliters per minute for argon. So this is going to be equal to the square root of, so on top we're going to use the argon, and you look at the periodic table to get the mass of argon, which is 39.95 over the molar mass of the unknown, so that's just X. So now we're going to solve this for X. So first we're going to square root everything. So now we're going to have 38.2 over 58.0, square that, and that should be equal to 39.95 over X. Now you're going to multiply by X. So now we're going to have X times 38.2 over 58.0 squared is equal to 39.95. Now we're going to divide by the 38.2 over the 58.0 squared. That will cancel out. Divide by 38.2 over 58.0 squared. And after you calculate this, you should get 92.10 grams per mole. So this is the molar mass of the compound. Now to get the molecular formula, we're going to divide our molar mass that we just found, which is the 92.10. And we're going to divide that by the molar mass of the empirical formula, which was 46.09. And after you divide these two, you should get around 2. And now we're going to multiply 2 by the empirical formula, which was CH6 and N2. Multiply that by 2, which will give us C2H12 and 4. And this is our molecular formula.